I'd like to say a few words about upgrading and share with you a glimpse for my current project, which is different from the previous one, but it shares exactly the same characteristics of self-learning, learning by doing, self-exploration, and community building. And this project deals with K-12 math education, beginning with early age math. And we do it on tablets because we believe that math, like anything else, should be taught hands-on. So here's what we do. Basically, we developed numerous mobile apps, every one of them explaining a particular concept in math. So for example, let's take area. When you deal with a concept like area, well, we also provide a set of tools that the child is invited to experiment with in order to learn. So if area is what interests us, then one thing which is natural to do is to tile the area of this particular shape and simply count how many tiles it takes to cover it completely. And this little exercise here gives you a first sort of good insight of the notion of area. Moving along, what about the area of this figure? Well, if you try to tile it, it doesn't work too well, does it? So instead, you can experiment with these different tools here by some process of guided trial and error. And at some point, you will discover that one thing that you can do among several legitimate transformations is the following one. You can cut the figure, you can rearrange the parts, you can glue them, and then proceed to tile just like we did before. Now, this particular transformation did not change the area of the original figure. So a 6-year-old who plays with this has just discovered a clever algorithm to compute the area of any given parallelogram. We don't replace teachers, by the way. We believe that teachers should be empowered, not replaced. Moving along, what about the area of a triangle? So after some guided trial and error, the child will discover, with or without help, that he or she can duplicate the original figure and then take the result, transpose it, glue it to the original, and then proceed what we did before. Cut, rearrange, paste, paste, and glue, and tile. Now, this transformation has doubled the area of the original figure, and therefore we have just learned that the area of the triangle equals the area of this rectangle divided by 2. But we discovered it by self-exploration. So, in addition to learning some useful geometry, the child has been exposed to some pretty sophisticated science strategies, like reduction, which is the art of transforming a complex problem into a simple one, or generalization, which is at the heart of any scientific discipline, or the fact that some properties are invariant under some transformations.